The internet problem is more today actually. Okay. So we have already started the linear variable differential transformer. That is the differential transformer. It is going to induce us EMF in the secondary windings, which is we are going to the net output of that is difference between secondary winding 1 and secondary winding 2. We have considered that one. Okay, so this is the linear variable differential transformer here. Now it consists of one primary winding, two secondary windings. It has consist here now. So this is a passive inductive transducer which does not require any supply or required any supply here. Passive means which required the external supply, that is called passive transducer we are going to call here now. So we are going to provide the supply for the primary winding. So it consists one primary and two secondary windings. So and it also in between the primary and secondary windings, we have placed one soft iron core material with handle or arm. The displacement arm we have provided here now to shift that one, to push into the right side and left side to take that one here now. So based on that, the soft iron core position also it will matters for the EMF induced in the secondary windings here. So for that reason, this one, based on this moment of the soft iron core, we are going to measure the displacement in the form of voltage we are going to measure here. So see here, when primary winding, we are going to provide the AC source to the primary winding, and secondary winding, the EMF will be induced here now. So S1 and S2 here. So the differential transformer, we told that one. So the connection we have made like this, positive, negative, and this is positive, negative here now. So the primary and secondary, we have made connection in series here now. So the net output of this secondary winding, S1 and S2 is S1, ES1 minus ES2, we are going to call here. EMF induced in the secondary winding 1 minus EMF induced in the secondary winding 2, we are going to call that. EMF induced in the secondary winding. Total EMF induced, total output of the secondary winding is ES1 minus ES2 or E1 minus E2 also we are going to call that. When the primary winding is excited by an AC current, it produces alternating magnetic field here now. When we will pass the signal current into this coil, it will produces the alternating AC magnetic field will be produces here. Now this alternating magnetic field, it is going to induce us voltage in both secondary windings S1 and S2 here. So EMF induced in the coil S1 is E1, EMF induced in the coil S2 is E2, we have considered here now. So the differential output is E1 minus E2, that is the differential output here. So based on the operation of this displacement of this core, it has three cases we have described here now. So one is at normal position when I will push this core into the right side and left side here now. Based on that, it has three cases. All the three cases we are going to discuss here. That is case 1, null position we are going to call here now. Is it audible? Audible hai kya nahi?
Yes, sir.
Okay. Up to here, we have discussed in the yesterday class only. From here, what you will do, null position means the core is at center of that both primary and secondary winding here. It is at center we have placed here now. It is not there at, not connected more on the secondary winding S1, not connected more on S2 here. It is some part of equally half part of the core is connected to the S1 and the same half part is connected to the S2 here now. So the magnetic field connected between from primary to secondary, that S1 and S2 is equal here now. Because of this equal magnetic field, the EMF induced in the coil E1 equal to E2. E1 equal to E2 is there, and there is no displacement at all in the core here now. For that reason, this is constant position or a starting position, initial position we are going to call that one. So for that reason, null position we are going to call this one here now. We have not connected, not taken this one into left side or not taken into right side here. At standard position, we have fixed that one. So that is null position we are going to call here now. So same part is connected to the S1, same part is connected to the S2 here now. So the magnetic field connected to the S1 and S2 is equal, means the EMF induced in the coil S1 is equal to the EMF induced in the coil S2 here now. So the net output of this one equal to, then E1 equal to E2 means the net output of this one, output voltage of the secondary equal to 0. For that reason, there is no output at all. So null position we are going to call that. When the core is at null position for no displacement, there is no displacement at all, that one we are going to call as null position. And when the core is at null position, then the flux linking with both the secondary winding is equal. It is at null position means the flux linkage between the primary to secondary is equal to both S1 and S2 here now. So for no displacement, the value of output is 0, as E1 and E2 are equal here now. So it shows that no displacement took place, that is E1 equal to E2 and E output total EMF induced equal to E1 minus E2, that is equal to 0. In the null position, the output voltage of the secondary is 0. Next, we will go for the second one, the position 2 here now. The position 2, just a minute, some corrections are there. Okay, the case 2, that is called left to the null position here now. The whatever the core is there inside that one, it is not at center here now. We have taken that one into left side here now. The left side we have taken here now. Because of this core is left side, so the maximum flux linkage is connected to the S1 here. The flux linkage of secondary coil S1 is more than the EMF induced in the secondary coil S1 is S1, that is called E1, is greater than E2 here now. So EMF induced in S1 is greater than EMF induced in S2, then E1 is greater than E2. We are going to call that E1 is greater than E2 here now. So on that situation, what is the net output? Net output will be positive or negative here now?
Positive.
Here now, because we know the formula, that is E1 minus E2. E1 is greater than, the E1 is positive, E2 is negative here now. So greater value sign we are going to use. So the output is positive here now. When the core is moved to the left of the null position for displacement to the left of the reference point, in this case, the flux linking with the secondary winding S1 is more as compared to the flux linking with S2. So due to this, the EMF induced in the S1 is E1 will be more as that of EMF induced in the S2, that is E2 here now. So due to this, output voltage E out is positive here now. For the left position of the left of null position, the output is positive. So that is called second case we have discussed here now. The third case is the right of null position here. Instead of this left side, when I will push this core into inside that, so right side, the displacement we have done here now. So the maximum flux linkage is on secondary S2 here now. S2 here now. So in this condition, right of null position, the E2 is greater than E1. E2 is greater than E1. Then what will be the output? Positive or negative? Negative, because we already know the formula that E1 minus E2 here now. E2 is greater, the E2 sign is minus here now. So we are going to get the negative output here now. When the core is moved to the right of null position, in this case, the magnitude of E2 will be more as that of E1 magnitude. So due to this, the output E out will be negative here now. We know the formula E1 is less than E2 or E2 is greater than E1. Both are same only the sentence. So output equal to E1 minus E2, that is called negative we are going to get here. So the null position, there is output is 0. For the left of the position, the output is positive. Right of the position, the output is negative here. No? Can you draw the graph, any one of you? Can you draw the graph? Graph draw kar sakte? So you consider this one as E output. This is output here now. And you take the x-axis and y-axis here now. You take the x-axis and y-axis. That is called a displacement you take down. This is displacement. And here E out. E out here. How we have to draw the characteristics of LVDT here? Can anyone tell? Yes. Can anyone tell how we can draw the characteristics of LVDT? जब भी क्वेश्चन पूछते साइलेंट हो जाते हैं लोग. Yes. Okay. Leave that one. I will explain that. So already you told that one. For the null position only you consider. What is the for the null position? What is the output?
0.
0. For the null position, output is 0. So this one we are considering as 0 means the output is 0 for null position. This is. Yes. Yes or no?
Yes, sir.
So output is 0 at null position. This is the null position. You consider that one. So before that one, also I will take this one into left side here now. See here, it is on the null position. The output is, I can draw the output into 0 here now. I can draw the output into 0 here. That is null position. We can call it. Suppose if it is connecting to the left side, it is moving here now. Left side it is moving means the E out is, so E1 will be start to increase here now. E1 will start to increase and E2 will start to decrease. Yes, when this core I am shifting into left side here now. I am taking into left side here now. So I will start here now. It will comes here, then here, then here. The up to here I will connect the core here. Left side it is there. So on that condition, the output is positive. E1 minus E2 is positive only, na? When it is at left side. If it is left side, yes, then the output is positive. Already we have discussed this one. I will change that slide also. See here, it is left of the null position. Then the output is positive. Positive means this one we are going to consider as positive here now. And this one we are going to consider as negative here now. So how the left side displacement will start from the original position, null position, like that, the EMF induced will also start to increase here now. Yes, it is going to increase. Yes or no? Linearly it is going to increase here now. Jaisa displacement is increasing, like that, the output will also increases here now. Up to what? If it is connected here, idhar tak humne le liye, so maximum flux linkage is there, then it is going to increase here now. इससे छोड़ के इधर S1 है, हमने इधर connect किया तो, then I have taken here means the displacement is more. What is the output here? The flux linkage will be decreases again. Yes or no?
Yes, sir.
In the magnetic field, if you have shifted that one, linearly it is going to vary. If it is after some time, it is not connected, not in the magnetic field, what will happen? Then it is going to maintain the constant EMF, but there is no displacement at all here. The displacement will increases, but the output is not increasing over there here now after some time. Same thing for the next one. Which one? Right side of the position. Right side of the position here now. Here also, if I am connecting this one here, then slowly linearly starting up to some value, it is going to increase, and after some value, it will go out of displacement. That only displacement will be increases. The output will be same over there. So whatever this up to this maximum value, it is linearly vary. After this, it is non-linear here. Now at null position, the output is 0 here. Now this is for the right side. This is for the right side. This is for the left side here. Now it is the characteristics of the LVDT. We can call that one. I have shown here. Now this here. Now this is the diagram here. Now the displacement we are doing here. Now so when E1 is greater than E2, that is called positive. E2 is greater than E1, then that is called negative here. No, that is out of phase. We are going to call 180 degree out of phase. This is which is in phase of the with input over there. In phase with input here. Now see here at the null position, the output is 0, and up to some value we have defined here. Now up to this, it is under linear condition only. The input is directly proportional to the output. But after this linear range, it has some range, then the displacement only it is going to increase. There is no change in the output at all over there. There was no change in the output at all. So it is the characteristics of the LVDT. It is the characteristic of LVDT. Next, it has some advantages of LVDT is nothing but it is high sensitivity. The sensitivity is very high. The power consumption is very less. Frictionless construction is there. Frictionless means there is no rotating part or and all the things. The ruggedness is there and easy to operate. That is also we can call that one. But the disadvantage it has, the performance is affected by vibrations here now. Because of the magnetic field or flux, some vibrations will be produced and while doing the displacement also here. And temperature affects the performance here now. That is called performance of the LVDT here now. See the transformer, I think you have seen over there. The transformer, if you are continuously operating, means the temperature will be increases over there. Temperature will be increases. So the temperature will affect to this performance of the LVDT, and the vibrations also it is going to affect here now. Other than this it has some high sensitivity, ruggedness, function, friction. There is no rotating or frictional rotating parts and all the things, errors or also constructions and all the things over there. You can call that one. So application, I told that one while starting only. For the displacement measurement in the form of voltage, we are going to measure here now. It is electrical transducer, passive electrical transducer is used to measure the linear displacement. We are going to use useful in force, pressure, weight measurement as secondary transducer. We can use this one here. We can use this one as a secondary transducer for the measurement of displacement, pressure, force, weight. Can use this one here. So it completes the LVDT here now. It completes the LVDT. Any doubts? Any doubts in the LVDT?
No, sir.
Okay. Then we will go for similar operation is there. Operation is same. Only the diagram is changed here now. That is called RVDT. We are going to call that RVDT here now. So in the linear variable, we can consider that one. So linear displacement ke liye we have used LVDT. Here for the rotating part here now, it has some iron core is there. If it is, we are using for the linear displacement means we have used LVDT. If it is a rotating part, then that is called RVDT. That is called a rotary variable differential transformer. Rotational variable differential transformer or rotary, we can call that. RVDT full form stands for rotary variable differential transformer here. So it is an electromechanical type here now. We are using electromechanical type of inductive transducers. So electromechanical type transducer. So that converts angular displacement. In the angle displacement is there, angular displacement into the corresponding electrical signal. Whatever the angular displacement is there, here 90 degree is there here. Now if it is come to the 30 degree, then how much it has displayed? If it is went for the 120 degree, then how much it is difference here. Now like that, angular displacement we are going to measure by using this rotary variable differential transformer here. So it converts angular displacement into the corresponding electrical signal, that is called in the form of output voltage only we are going to consider here now. As RVDT is an AC control device, we are giving the alternating supply to this. So there is no any electronic component inside that here now. Again, we are not using any electronic components inside it here now. It is the most widely used inductive sensor. It is most widely used inductive sensor we are going to use due to its high accuracy level. Its accuracy is very high. Since the coil of RVDT is designed to measure an angular position, so it is also known as angular position sensor also. What is the angle of position sensor? If we are launching a satellite, inside that one some parts are there. What is the angle of that one? What is the angle, how it is rotated? The thrusters are there, batteries are there, how they are going to rotate. Some panels are there, in which angle they are used. So for the angle detection, we can use this one as a sensor for that one. It is also known as angular position sensor. We have called this one. So this is the diagram of RVDT here now. Rotary variable differential transformer here. Will you see this diagram? Is it visible?
Yes, sir.
Yes. Is it visible?
Yes, sir.
See here, you just compare with LVDT here now. What is the difference here? Just compare with LVDT. You can compare with LVDT here now. Is there any difference between LVDT and this one? I am asking to you only. What is the difference? You tell me, that's it. Comparing with the diagram, what is the difference of LVDT and RVDT?
Core is placed horizontally.
Core is placed horizontally. And there also we have placed horizontally. No? Doesn't matter horizontal or vertical, whatever it may be. If it is placed in the horizontal, it is there means there is no part linked to the S1 and no part linked to the S3 here. No. Directly it is linked here only. Directly it is linked here only. See here, this RVDT also consists of two coils only. One is primary, second one is secondary coils. The secondary, it has two windings again. Secondary winding has two windings, that is called S1 and S2 here. Now the EMF induced, because of whenever we will give the supply to the primary, the magnetic field will be produced. Because of this alternating magnetic field, the EMF will induce us in the secondary winding S1 and S2 here. Now, so based on this connection, the net output of the secondary winding is the difference between EMF induced in secondary S1 winding and S2 winding here. So EMF induced in the S1 winding is ES1 we have considered. EMF induced in the S2 is ES2 we have considered. So the net output of secondary is E0 equal to ES1 minus ES2. See here, in between the middle of primary and secondary winding, we are using one core material here now, and which is connected to the shaft. This is a rotating part here. This core is a rotating part here. It is a rotating part here. It indicates that it is not connected to the S1 and not connected to the S2 here. Actually, the null position we are going to call this one here. If it is not connected to anything, then it is null position. Or same thing we can connect like this also. The vertical angle also we can call this one. See here. Yes, it is also null position. same part, it is connected to the S1 and S2, it is connected same part here. So null position, again, the difference output is 0 at null position here. Null position. Again, at the here, if it is clockwise direction, it is rotating in the clockwise direction, then this part, it will come nearer to this one, S1. Yes?
Yes, sir.
So on that condition, the positive output will become, because ES1 is greater than ES2 here now, and during the clockwise direction. During the anti-clockwise direction, if it is rotating in this time, so this shaft is there, it will come here, core, and this shaft core is there, it will come nearer to this one. On that condition, the negative output we are going to get here. Like that, here also 3 cases are there here. In this condition also 3 cases are there. One by one we'll discuss here. Now before that one, the construction, I told that one, the design and construction of RVDT is similar to LVDT only. It is similar to the linear variable differential transformer only, but only the angular displacement we are going to measure in this RVDT, but linear displacement we have measured in the LVDT. The only difference is that shape of the core in the transformer winding here now. The shape of the core is different here now. LVDT uses the soft iron core to measure the linear displacement, where RVDT uses the cam-shaped core, that is called rotating core, we are going to use for the measurement of the angular displacement here. Rotating displacement, angular displacement we are going to measure here. So working, I told that one, the working principle of RVDT and LVDT both are same and based on the mutual inductance principle. When AC excitation of is given to the primary winding, applied to the primary winding of the RVDT, then a magnetic field will be produced inside the core over there. So this magnetic field induces a mutual current in the secondary windings. Mutual, it is going to induce us EMF in the secondary windings. Then due to transformer action, the induced voltage in the secondary winding S1 and S2 are ES1 and ES2 respectively. So EMF induced in the secondary winding S1 is ES1, EMF induced in the secondary winding S2 is ES2 here now. Hence, the net output of the secondary winding will be the difference between ES1 and ES2 here now. Hence, the net output voltage will be the difference between the both induced secondary voltage here now. That is called output voltage E0 equal to ES1 minus ES2. ES1 minus ES2 here now. Based on this formula, if ES1 equal to ES2, then output equal to 0. That is called null position. Case 1 we are going to consider. If ES1 is greater than ES2, then answer will be positive. Positive, that is positive position we are going to call. If ES2 is greater than ES1, then we are going to get negative answer here. Based on this, we have considered, that is 3 cases are there again here now. But this one is null position, we will use that one. But this one, the positive and negative, it is not whatever the left and right, it is angular is there, clockwise and anti-clockwise. Based on that, we are going to call here. This is for the clockwise, this is for the anti-clockwise. Negative we are going to call here. I will show that one, I will tell you. One by one case we are going to discuss here. Now, according to the position of the core, there are 3 cases that arise. So let's discuss 3 cases one by one in detail here. Case 1. When the core is at null position over there. Null position we are going to consider here. It is null position means the core I will consider like this here. So this is the shaft here. This is the shaft. Here secondary winding is there, one S1, and here another secondary winding is there. So it is equally, it is connected to the S1 and S2 here now. Equally it is connected to the S1 and S2. So EMF induced in the S1 is equal to the S2 here. So when the core is at null position, then the flux linkage with the both the secondary windings will be same. Equally it is linking means the EMF induced in the both the secondary windings will be same only. Yes. So the induced EMF in the secondary winding S1 is ES1 and S2, that is called ES2, in both the windings will be same over there. So EMF induced will be same. According to this, we know the formula, that is E naught equal to ES1 minus ES2. This one. So ES1 equal to ES2 means what is the output? The output will be 0. So it shows that displacement of the core is 0 here. There is no displacement at all. There is no displacement at all here. That is null position, we are going to call that one here. Same like LVDT. LVDT जैसा है ना ये भी operation? Yes?
Yes, sir.
Next one. The second position, second case I will take for the RVDT. When the core rotates in the clockwise direction. Clockwise direction. Every time I will draw the diagram. See here now. So this is the core is there, middle core is there. Okay. Here the S1 is there. Here the S2 is there. Okay. So clockwise means this side only, na? Clockwise means this side only, na? Yes? Yes or no? Right side here, no. So right side means clockwise means it should have to rotate like this. Yes, left to right. And that situation, if it is rotating like this, means this upper part will come nearer to the S1. Yes, it will be the clockwise direction means the core is there. It will come like this. Yes.
Yes, sir.
It will be like this. Then which winding is linking more magnetic flux? It is nearer to the S1 or S2 here now?
S1.
S1 here now. It is nearer to the S1. Then this angular displacement is there. This angular displacement we are going to measure in the form of output voltage here. So from this condition, we can say that one ES1 is greater than ES2. Easily we can say that one ES1 is greater than ES2. Then what is the formula? ES1 minus ES2 is there. So answer will be in positive or negative?
Positive.
Positive. When the core rotates in the clockwise direction, then the output will be positive here now. The output will be positive here now. See here, when the core RVDT rotates in the clockwise direction, then in this case, the flux linkage with the S1 will be more as compared to S2 here. See here, I am practically showing here now. See, S1 is connecting more, no? It is nearer to the S1, and S1 is connecting more flux linkages as compared to S2 here now. So the EMF induced in the S1 is greater than EMF induced in the S2 here now. So hence ES1 is greater than ES2, and the net differential output here also differential output only we are using here now. So ES1 minus ES2. ES1 is positive, ES2 is negative. The greater is ES1. So the output is positive here now. The output will be positive here now. This means that the output voltage E0 will be in phase with primary voltage here. The primary we are providing positive or negative voltage here. The positive we are providing here now. So the output will be is in phase with primary or whatever the input supply here. Now we can say that. We can say that. Next, case 3, I will take that one. Next, case 3. When the core rotates in the anti-clockwise direction, when the core of the RVDT rotates in the anti-clockwise direction, again I will take the diagram. See here now. Initially, this is the core is there here now. Core is there. Here the S1 is there. Here the S2 is there. Here the S2 is there. Then anti-clockwise direction means here it is rotating like this here now. It is rotating like this. Then after rotating like this, this one, the core movement will be like this here now. Core movement will be like this here. The red color line here. So the core is linking with the secondary winding S1 or S2 here now? More.
S2.
S2 is the flux linkage of S2 will be more here now. If the S2 is linking more and which is near to the S2, then EMF induced in the S1 is greater or S2 is greater?
S2 is greater.
EMF induced in the S2 coil, secondary coil S2 is greater than EMF induced in the primary secondary S1 coil here. Now, so we can say that one ES2 is greater than ES1. You can say that ES1 is greater, sorry, ES2 is greater than ES2 here. No, so the net differential output will be negative here because ES1 minus ES2 is the differential output we are going to get. The output will be negative here. Now, when the RVDT core rotates in the anti-clockwise direction, then the case the flux linkage with the S2 will be more as compared to S1 here. Now, this means that induced EMF in S2 will be more than induced EMF S1 here. Now, so the net output of differential output will be negative here. So the output is in negative means the output is in phase with the voltage or in out of phase with input. The output is negative here now. Okay, the input is positive here now. So output is in phase with input or output is out of phase with input. See here the positive is there, here the positive is there. The output will be out of phase. That is called 180 degree out of phase. We can call that one. We have written here now in phase, but opposition we have written here now. See here, the value is same, but opposition here now, opposition to 180 degrees out of phase here now. The positive and negative, what is the phase difference is 180 degrees there. From here to here 180 degree only, na? This angle.
Yes, sir.
This is 90 and this is 90. 90 plus 90 is 180 degree here. So 180 degree out of phase, we can call that one. These are the three cases of RVDT are there. These are the three cases of RVDT. Any doubts here?
No, sir.
Same are there? Sounds like me talk. So the operation of LVDT and RVDT is same here. Only that is angular displacement we are going to measure for the RVDT here now. Rotational angular displacement here now. So it has some advantages. The RVDT also has some advantages, that is called high accuracy as compared to the LVDT. The accuracy of this one will be high, angular, and compact. The size will be compact here now. For the LVDT, it is for the angular x-axis left to right movement was there, so it was size was bigger. But here only at the center point we are using here no rotating part, so size of that one is compact size and strong construction is there. The consistency of RVDT is high, long lifespan is there, very high resolution is there, cost is less, high durability, linearity is excellent, the performance is repeatable here now. It is not like that एक बार अभी एंटी क्लॉकवाइज में हो गए वो खत्म हो गए नहीं है ना, ऐसा continuously it may be rotate in the clockwise direction and anti-clockwise rotation, so you can repeatably it can perform that one, and it is easy to handle also. These are the advantages are there. The applications where we are going to use this one, RVDT is mostly used as a sensor nowadays. I told that one in a satellite centers, whenever we are going to launch that one, what is the position, we can do that one. In the manufacturing industries, we can use that one. It is used as a sensor nowadays. Also, it does not experience any functional problem due to its contactless. It is not contactable. एक primary को और core को touch होते ऐसा कुछ नहीं है. There is no contactable terms. Hence, the main application of RVDT include the following here now. First one, actuators for controlling the flight as well as engine here. Flight ऐसा same straight जाते क्या, ऐसा movement वगैरह नहीं होते क्या? Yes, it is going to do movement. Hello.
Yes, sir.
So which angle it is moving, that one we can use in the flights also. We are going to use this one, and fuel valve as well as hydraulics we are going to use over there. Every one of you are using your vehicles in that one. What is, we are going to turn that one left side को turn हो गए तो the petrol diesel fuel valve also we are going to consider. Just a minute. बोलो sir. So it can use as a fuel valve as well as hydraulics we are going to use. Brake with the cable system. In the cable system also we can use here now. Modern machine tools we can use that one, where it has stopped over there in a manufacturer companies and all the things. Anywhere it has some Coca-Cola manufacturing factories are there, one bottle to another bottle they are going to move over there. So if anywhere problem is there, like that we are going to use. Nose wheel steering system we can use. Steering we are whatever we are going to rotate that one here now. Weapon and torpedo system, engine fuel control system, aircraft and avionics we can use here now. Engine blades, air system, robotics here. So many applications are there for the RVDT as compared to the LVDT, because it is angular displacement we are going to measure here now. For that reason, comparing with the LVDT, the RVDT applications are more as compared to the LVDT here. So it completes the transducers. According to your syllabus, there is, according to your syllabus, so the transducer part is over here now. LVDT, RVDT up to here. RTD is over. RTC is over. Resistance temperature coefficient, classifications of transducer, electrical transducer, in that one RTD, RVDT, LVDT. These three transducers we have discussed here now. That is LVDT, RTD, LVDT, RTD. It completes the transducers parts. Next we will go for the second part of the chapter 4, that is called instrument transformers. That is called instrument transformers. So if you have any doubts in the transducers, you can ask before starting the new topic. If anyone want to ask any questions. Any questions? Unmute किए क्या नहीं मैंने? Hello, is it audible?
Yes, sir.
Any questions?
No, sir.
Okay. We'll go for the new topic, that is called instrument transformers here. So for the instrument purpose only, we are going to use some transformers. Instrument purpose means for the measurement purpose only here, which should not affect to the measuring instruments. Measuring instruments को कोई effect नहीं होने का. High voltage are there, high currents will be there. Like that, we are going to use some instrument transformers. That is, instrument transformers are used in AC system for measurement of electrical quantities. to measure the voltage, current, power, energy, power factor, frequency. So we required the instrument transformers are required for that one. Now in your house, our houses, we are going to use 230 volt, but from the transmission we are going to use 220 kV, 2,20,000 voltage we are going to get that one. So voltage कितना है बोल के check कर सकते क्या आप जाके उधर? I think you may heard the some accidents also. Whenever you will away from 6 feet also, when you will go 2 feet away, automatically it is going to give the electrical shock. Surrounding that, the electrical field will be produced over there. You should not go near to that voltage or that cable line and all the things. So it is not possible to measure the high voltage and all the things. For that reason, to measure the voltages, we have to reduce that voltage into low level. We have to measure, and as per the turns ratio, we have to calculate that voltage. Based on that, to measure that voltage, the transformers are required. Those transformers are called as instrument transformers. We are going to call it. Instrument transformers are also used with protective relays for protection of power system. Directly we will not use this instrument transformers also. With some relays we are going to use for the protection purpose of power system here. So the basic function of instrument transformers is to step down the AC system voltage and current here. Whatever the high voltage is there, we have to step down, and current we have to reduce that one. Step down we have to do. Then we can measure, we can give to the any instrument for the further measurement applications here. So the basic function of the transformer, instrument transformer, is to step down. In the instrument transformer, we are going to step down only. Step down the, we are going to step down, where yes, step down the AC system voltage and current here now. So the voltage and current level of power system is very high. The voltage and power system, the voltage and current level of power system is very high. So it is very difficult and costly to design measuring instrument for the measurement of such high voltage level here. I told that one 220 kV is nothing but 2,20,000 voltage is there. वो measurement करने के लिए हमको उसका design चाहिए. Like a one big house, that much bigger instrument is required. So that is not possible. Possible, but the design is difficult for that one, and it is costly to design also. For that reason, we are going to use the instrument transformers here now. So what it will do? Generally, the measuring instruments are there. These are designed for 5 ampere and 110 volts. Voltage, input voltage, whatever it may be, it is going to bring that one into 110 volt, and the current, whatever it may be, it will bring that one into 5 ampere. So this instrument transformer capacity, it is going to bring the current and voltage into lower level. It is going to bring that one. Some applications of instrument transformers are there to measure the high value of electric current here. No, to measure the high value of electric current, we are going to use the current transformers. For the measurement of high voltage or electrical voltage or potential difference, that is called potential difference transformers we are going to use. To measure the electrical power with uses of both CT, PT here. Here it will give the current value, it will give the voltage value. Potential difference means voltage or current?
Voltage.
Voltage only here, no. So easily we can find the power, we can measure that one here now. Power measurement we can measure here now. So to measure the power with uses of both CT, PT, by we can measure the power here. So voltage measurement, current measurement, power measurement, even we can do the frequency also. So from this instrument transformers, it has some advantages also. The large voltage and current of AC power system can be measured by using small rating instrument. Very high voltages we can bring into lower voltages up to 110 to 120 voltage only. kV to volts we can convert that one. The current also very high currents, 50 ampere, 60 amperes currents we are going to bring that one into 5 ampere or 1 ampere or 2 ampere also we are going to bring here. So instrument transformers provide electrical isolation between high voltage power circuit and measuring instruments. This, whatever the step down we are doing, here only for the measurement purpose and protection purpose we are going to use here. No, so in between this measurement circuit and high voltage circuit, we are separating by using isolators over there. We are going to isolate that one here. So which reduces the electrical insulation requirement for the measurement here now. It can be reduces the insulation requirement, it is going to reduce, and the protective circuits, and also assures the safety of the operators here now. To assure the safety of the operators, we is going to measure, we have to isolate the main circuit or high voltage power circuit, and measuring circuit we are going to isolate that one here now. That is the main advantage here now. Several measuring instruments can be connected through a single transformer to a power system. One potential transformer, from one potential transformer, we can connect so many instruments, measuring instruments we can connect and measure that. One CT or PT we can call that. Due to low voltage and current level in measuring and protective circuit, there is low power consumption in the measuring and protective circuit here. The voltage and current we are reducing into low, then the power consumption will be obviously it is less only. The power consumption is obviously it is less only here. So mainly the instrument transformers are classified into two types here. The instrument transformers are classified into two types, that is current transformer and potential transformers here. The current transformer and potential transformer. Potential transformer is nothing but to step down the voltage. The current transformer is step down the current here. Now, one by one, these we are going to discuss in the next class. The current transformer and potential transformer we are going to discuss in the next class. We'll discuss that one. Just a minute. Roll number 1, 2, 3. 3 nahi hai. 4, 5, 6. 9 is present today. Okay, 1, 12, 13. Roll number 14. 16. 17, 18, 19. Roll number 19. 20. 21, 22, 23. 24. 25, 26, 27, 28, 32, 33.
30 present, sir.
30 is present. I am asking 32, 33. $36, 39, 40, 42, 43. Okay, we'll stop here only. See here, at 3:30 to 4:30, the mentoring session is there. To come the mentoring session, all of you should know your fee pending. What is your category? For your category, how much fee was there and how much you paid? What is the balance? This one we are going to discuss. All the students, you have to remember, you have to join for 3:30 session today.